Hello students, welcome to this new lecture. In this video, we are going to understand the concept of diffusion and solve the following question from previous year GATE Metallurgy branch. So, this is first question is from GATE 2008 from Metallurgy branch. Second question is from GATE 2010. Third question is from GATE 2013. The next question is from GATE 2022 and last question is from GATE 2015. So first of all we will understand the concept. First concept is Fick's first law. Fick's first law. This is also called steady state law. According to this expression, flux J is defined as flux J equals to minus d dc upon dx, where J measured in mass per unit area per unit time and unit is mole meter square per second. D is called diffusivity or diffusion coefficient. Unit is meter square per second. dc by dx is called concentration gradient. Unit is mole divided by meter to the power 4. Next, the D diffusivity is defined as D equals to D naught exponential to the power Q by RT, where D naught is diffusion constant with unit meter square per second. Q is activation energy needed for diffusion. Unit is joule per mole. R is called gas constant. Unit is joule per mole per Kelvin. T is the temperature in absolute unit Kelvin. Next we are going to understand Fick's second law. This law is also called non-steady state law. According to the expression dc upon dt equal to diffusivity into double derivative of concentration with respect to position, or we can also write del C concentration A upon dt equals to diffusion del square concentration of A. So this is in the differential form. After finding the solution and applying the boundary condition, the solution converges to Cx comma t equals to A minus b error function x by 2 root dt, where A is called Cs. It is average surface concentration. B defined as Cs minus C naught, where C naught equals to initial concentration at distance x. Cxt is concentration of the diffusing atom at a location x at time t, equilibrium time. This has mainly two applications. One is decarburization and other one is doping of semiconductors. If we want to draw a diagram, suppose that this is a material, then we will draw a concentration profile. At the surface, the concentration is higher, it's CS, and with the distance it decreases with this concentration as C0. There are some extra information. ERF function is given by 2 by root pi integration from 0 to x by 2 root dt exponential minus y square dy. Second one, if ERF function is very small, then ERF y becomes almost y for very small value of y. ERF infinity becomes 1, ERF minus infinity becomes minus 1, ERF 0 becomes 0. As this is an odd function, so ERF of minus y, it will become minus ERF y. Now we are ready to solve the question. Moving to the question. So we will solve the first question from GATE 2008. In this question, the diffusivities of carbon in gamma iron at 1173 and 1273 kelvins are given as this and this respectively. We have to calculate the activation energy for diffusion in kilojoule per mole. So now we will use the first formula where D diffusivity is equals to D naught exponential minus Q by RT. We have to find the Q, the activation energy. We can write D is proportional to exponential minus Q by RT. So there are two cases given at two different temperature and their diffusivities are given. Now we can write D2 by D1 equal to exponential minus Q by RT2 by exponential minus Q by RT1. Now D2 by D1 equal to combining the exponential terms, exponential minus Q by R 1 by T2 minus 1 by T1. Now taking the natural log on the both side, we will get ln D2 by D1 equal to minus Q by R 1 by T2 minus 1 by T1. Further we can write ln D2 by D1 equal to minus Q by R T1 minus T2 by T1 T2. Now Q equals to minus R ln D2 by D1 into T1 into T2 by T1 minus T2. Now after substituting the value, Q equals to minus 8.314 joule per mole per Kelvin into ln D2 is 1.94 into 10 to the power minus 11 by 5.9 into 10 to the power minus 12 into T1 is 1173, T2 is 1273 by 1173 minus 1273. Q equals to minus 8.314 into 1173 into 1273 divided by 100 minus 100 into ln 1.94 into 10th power minus 11 plus 12 by 5.9. My negative sign will get cancelled. After solving in calculator, we will get Q equals to 147744.81 joule per mole. In kilojoule, we will get 148 kilojoule. So option B is correct for question number 71. Now we will solve question number 72. Question number 72 is the diffusivity of the carbon in gamma iron at 1373 degree Kelvin. So we have another temperature here, 1373 Kelvin. Let's call it T3, 1373 Kelvin. Now similar to the previous question, D is proportional to exponential minus Q by RT. Again, like the previous case, we can take the ratio. This time we will take the ratio of D3 upon D2. D3 is the quantity we have to determine here, the diffusivity of carbon at 1373 degree Kelvin. So equal to exponential minus Q by R T3 divided by exponential minus Q by R T2. After combining the exponential, we will get D3 by D2 equal to exponential minus Q by R 1 by T3 minus 1 by T2. Now D3 equals to D2, that is 1.94 into 10 power minus 11. 1.94 into 10 power minus 11 into exponential minus Q we have determined in the previous question, 148 into 10 power 3 joule per mole, and R we know 8.314 into 8.314 joule per mole per Kelvin into its T3 minus T2 upon T2 into T3. Substituting the value, we know T3 is 1373, T2 is 1273, 1373. On calculation, we will get D3 as 5.37 into 10th power minus 11 meter square per second. So for 72 number question, option C is correct. Now we will go for question number 73. During the decarburization of steel, in case of depth D has been obtained in 40 hours. Depth D is obtained in 40 hours at 1173 degree. And for achieving the case depth of D by 2 at temperature 1273 Kelvin, the time required we have to find. So depth x1 is given as D and x2 depth is given as T by 2. T1 is given as 40 hours and we have to determine T2. We already know the diffusion at 1173 and 1273. These are D1 and D2. D1 and D2 we know. It's given. From the Fick's second law, we know C x comma T equal to A minus B error function of x by 2 root dt. Now we have to understand that inside the error function x by 2 root dt is a constant term for a particular set of material. So we can write x by root dt equal to constant. Then x1 by root d1 t1 equal to x2 by root d2 t2. From here we have to determine t2. t2 equals to x2 by x1 to the whole square into d1 by d2 into t1. So after substituting the value t2 equal to, we will get as d2 by 2 d for x1 to the whole square into 5.9 into 10th power minus 12 by 1.94 into 10th power minus 11 into t1 as 40 hours. After calculating, we will get t2 equals to 3.04123 hours, which is approximately t2 equals to 3 hours. So question number 73, 3 hours is the correct answer. So now we will move to the next set of question. This is GATE 2010 question. In this question, the diffusion couple shown above is made up of two alloys A and B. The initial composition of the two alloys are indicated in the diagram, that are NB equals to 0.4 here and NB equal to 0.5 on the other side. The center line is at distance x equal to 0. So this is x equal to 0. The couple is held at an elevated temperature for 40 hours. So it is held for 40 hours. Diffusivity is given. Assume the diffusion couple to be infinitely long. Question number 54. Which of the following parameter give the composition profile in the given form? So from the Fick's second law, we know that Cxt equal to A minus B ERF x by 2 root dt, and the given expression here is Cx comma t equal to C1 plus C2 ERF x by 2 root dt. Easily from we can say that A equals to C1 and B equals to minus C2. We have already defined that C1 is the average surface concentration. So with these two couple held at x equal to 0, the C1 value will be average of both of these two. So it will be 0.4 plus 0.5 by 2. It will be 0.45. And we know that now CS we have got as 0.45 minus C0 is bulk concentration, which is 0.5 equal to minus C2. So C2 equals to plus 0.05. C1 is 0.45, C2 is plus 0.05. So option A is correct. Next question, 55 number. The composition at a distance x equal to 0. The composition at a distance x equal to 2 mm is approximately, assuming ERF x equal to x. Now using the same relation, C x comma t equal to 0.45 plus 0.05 ERF x by 2 root dt. So now we will substitute the value. X is the depth given as 2 mm. This diffusivity is given as 3 into 10 power minus 11. Time is given as 40 hours. After substituting the value, Cx comma t will be 0.45 plus 0.05 error function 2 into 10 power minus 3 to convert into meter divided by 2 into root. Diffusivity is 3 into 10 power minus 11 into time is 40 hours into minute into seconds. So we will get 0.45 plus 0.05 inside the error function. After calculating, we will get Now as it is a very small value, so we can write this to 0.48 directly. So after calculating we will get 0.45 plus 0.05 into 0.48. It will be 0.45 plus 0.024. So finally after calculating we will get C x comma t as 0.474. So option B is correct in this case. So now we will move to the next question. This is another question from GATE 2013 paper organized by IIT Bombay. First we will read the question. A steel specimen containing 0.2 weight% carbon is carburized in an atmosphere that maintains a carbon of content 1.2 weight% carbon at the surface of the specimen. Given for carbon diffusion in austenite, activation energy is given Q as 142. We have given a data to calculate the error function. First question is, what is the depth in micrometer from the austenite surface of the specimen at which composition is 0.4 weight% carbon is obtained after carburizing at 870 degrees Celsius for 10 hours. From the fixed second law of diffusion, Cxt equal to Cs minus C naught ERF x by 2 root dt. First of all we will write the given information, like the bulk concentration C naught is given as, so steel specimen has 0.2 weight% carbon. Surface concentration Cs is given as 1.2 weight% carbon. Cxt is given as 0.4 weight% carbon. This is the carbon content where we have to determine the depth. So we have to determine the x finally. Before that we also need to determine value of diffusivity. So we will start from diffusivity calculation. D equal to d naught exponential minus q by rt. We will substitute the value as d naught is given in the question as 2 into 10 power minus 5 exponential minus activation energy is given as 142 kilojoule value of R is 8.314 joule per mole per Kelvin into temperature in the absolute scale is 870 degrees Celsius. Temperature is 870 degrees Celsius, so we will convert into absolute scale as 870 plus 273 Kelvin. It will be 3, 4, after calculating we will get 6.478 into 10th power minus 12 meter square per second. Now proceeding to the carburization part, we will write fixed second law of diffusion. We will write this expression as C x comma t minus Cs by C naught minus Cs equal to ERF x by 2 root dt. Now we will substitute the value. Cxt is 0.4 minus Cs is 1.2 by C naught is 0.2 minus Cs is 1.2 equal to ERF x by 2 root dt. It will be 0.8 equal to ERF x by 2 root dt. We have to calculate the value of ERF. So we will calculate the value of ERF from the given information, that is this one. So from the given information we will use the interpolation function to calculate the value of ERF function of 0.8. So we will calculate by doing 0.95 first one minus, let's suppose we have to determine the value of y, divided by 0.90 minus 0.85. Similarly, we will take the value from the right side also. ERF corresponding to the 0.95, we have value of 0.8209 minus, we have to determine the value corresponding to y which is this one 0.8 divided by, corresponding to 0.9 we have 0.7970 minus, corresponding to 0.85 we have this one 0.7707. After this we can write 0.95 minus y equal to, after calculating this we will get 0.05. From numerator we will get 0.0209, and from calculating denominator we will get 0.0263. So it will be 0.05 into 0.0209 divided by 0.0263. Now directly we will calculate y equal to 0.95 minus, it is 0.03973. So y will be 0.910266. After calculating this we can remove a error function and we will write x equal to 2 root dt equals to 0.910266. Now again, after substituting all the value as x by 2 into root diffusivity, we have calculated as 6.47 into 10 to the power minus 12 into time given as 10 hours into minute into seconds as equal to 0.910266. Now after calculating we will get x equal to 879 into 10 to the power minus 6 meter. So it will be 879 micrometer. So from this we can see nearest option is D. So option D will be correct for this question. Now we will calculate for question number 49 of 49, the second part of this question. In the previous question we have already seen this relation x by 2 root dt equal to constant. So we will use this relation for the second part. From the question we can see that how long in hour, so we have to find the time, will it take to double the depth at which 0.4 weight % carbon is reached. So depth is doubled and we can notice the weight % carbon is same as in the previous case and temperature is also not changing, so D will remain constant. So final expression we can write x directly proportional to root t. So we can write x2 by x1 equal to root t2 by t1. x2 is 2x1 equal to root t2, we have to determine that t1 is 40 hours. Sorry, it's 10 hours. So we can write 2 equal to root T2 by 10. So it will be T2 equal to 10 into 4. It will be 40 hours. So for this question, option A is correct, 40 hours. Now we will move to the next question. So this question is from GATE 2015, question number 51. It takes 10 hours to homogenize an alloy at 1273 Kelvin. The time required in hours to achieve the same extent of homogenization at 1373 Kelvin and diffusivity at two different temperatures are given. Given is diffusivity at 1373 Kelvin, 10 to the power minus 18 meter square second minus 1. Diffusivity is 1273 10 to the power minus 19 meter square per second. At 1273 Kelvin, it takes 10 hours. So time at 1273 Kelvin is given as 10 hours, and we have to determine time at 1373 Kelvin in hours. So we will use the relation x by 2 root dt equal to constant. We can write x directly proportional to root dt. Then, as given in the question, the extent of homogenization is same, means x is same in the both case. So we will write root dt equal to constant, so as d1 t1 equal to d2 t2. We have to determine the time for second homogenization, so it will be t2 equal to d1 by d2 into t1. So after putting up the values, 1 is for 1273 Kelvin and 2 is for 1373 Kelvin. So we will put d1 at 1273 Kelvin as 10 to the power minus 19 divided by 10 to the power minus 18 into time given as 10 hours. So it will be 10 to the power minus 1 into 10 hours. It will be 1 hours. So answer for this question is 1 hours. Now we will move to the next year question. This is a GATE problem of 2022. GATE 2022. The concentration C of a solute in a solid along x direction. So it has taken x as positive direction and there is some concentration variation in x direction. And the relation is given as C equals to a1x square plus a2x, where a1 and a2 are constants. Assuming a1 equal to a2 equal to 1, the magnitude of flux at x equal to 2 is, we have to determine. So this question is based on Fick's first law. We know that from the Fick's first law, flux equal to minus d dc by dx. By differentiating this, we will get dc upon dx 2a1x plus a2. We have to assume that a1 equal to a2. So we have to take a1 equal to a2 equal to 1. So it will be 2x plus 1. Concentration gradient dc by dx at x equal to 2 is 2 into 2 plus 1. It's 5. Now putting up the values, we will get diffusion coefficient of the solute is given as this one. So it will be 3 into 10 to the power minus 3 into dc by dx at x equal to 2 is given as 5. So it will be 15 into 10 to the power minus 3 atoms minus 2 second minus 1. So nearest integer is 15. So 15 is the correct answer for this question. Hopefully you have understood all the concept and the problems we have gone through. Thank you so much.